Today we're going to use component form to answer each of the questions that we answered yesterday. This is the exact same worksheet, so we need to get the exact same answers, but we're going to use component form to answer these. An airplane is flying with an airspeed of 310 knots on a heading of 50 degrees. If a 78 knot wind is blowing from a true heading of 125 degrees, determine the speed and direction of the plane relative to the ground. So let's start this down the bottom left, just like we did yesterday. And we're going to draw a vector representing the plane at roughly 50 degrees from north. So let's say about right there. And then we draw another XY axis. And we want to draw a 78 knot wind that is blowing from a true heading of 125 degrees. So 125 would be down this way. So from that would be about right there, let's say. Then we need the resulting vector, which is about right there. So let's label this as 310, and we can label this as 78. Let's get the component form of the vector for the flight of the plane, which is going to be 310 times the cosine of some angle. Now the angle we have to use is actually the unit circle angle, and that's going to be this angle right here. Well, if this one is 50, then this one, the unit circle angle, is going to be 40. So we have cosine of 40, and then we have 310 sine of 40, just like the unit circle, except instead of a radius of 1, we have a radius of 310. Really what we found is the x component, or once we use a calculator, the exponent and then the y component of this vector. Then we have the component form of this little vector right here, the wind. And so we need the x component and the y component. So the component form of the wind is going to be 78 times the cosine of, we need the angle. Well, if this direction right here was 125, that means this angle right here is 35 degrees. We'd have 90 and then another 35 to get to 125. So that means this angle right here is also 35 degrees. So if this piece is 35, then the unit circle angle, the angle we want right here, is going to add up to 180, so 145. So we need to use 145 degrees. So in other words, all we had to do was find the unit circle angle for this vector right here. Then we have 78 sine of 145. Now we want the resulting vector. We want vector P plus vector W. And so that's what we're trying to answer, the information for the resulting vector. Vector P plus vector W is equal to, now we go to our calculator, we'll turn this on, and we have 310 cosine of 40 plus 78 cosine of 145. Let's make sure we're in degrees. We're in degrees for this calculator. Press enter, and the component form of the resulting vector is 173.5799179. And then we need the y component, 310 times the sine of 40, and then plus 78 sine of 145. And we get 244.003121. And then we need to answer the first part of it, determine the speed. That's going to be the magnitude of vector P plus vector W. So we need to square what we have here, square, and then plus 173.5799179 squared. And we get 89,000, and then we take the square root of that answer right there, and we get what we got yesterday for this exact same problem, 299.4, and that's going to be knots. Now what we've done is we've found the component form of the resulting vector. So really, it turns everything really into a right triangle. So to find this angle right here, this one, the unit circle angle, we can take the inverse tangent of the y over the x. We have inverse tangent of the 244 and some change over the 173 and some change. And let's see what we get. We have 244.003121 divided by 173.5799179. And I guess I could have done this all in one shot, but then we take the inverse tangent of the answer. And we get, this is going to be 54.573, let's say, but that's the unit circle answer. What we want is the bearing. So we want that angle right there. So we have to take 90 minus the unit circle measurement. So we have 90 minus 54.573. So we take 90 minus the answer, and we get what we got yesterday for this very first problem. 35.4, actually 035.4 degrees. Your assignment is to do the rest of the problems using the component form this time, not what we did yesterday, but you should still get the same answers for every single problem.